special angles and corresponding points. Given W, the wrapping function, we spoke about the wrapping function last video. For every t, for every real number t, there is a corresponding point in the unit circle for that t. And that point is the endpoint of the arc in the unit circle whose length is t. But we are making these propositions. If t is pi over 4, the corresponding point for pi over 4 is this one. It has this pair of coordinates. And where is that in our picture? So starting from this point, our initial point, we will trace an arc whose length is pi over 4. And that is approximately 0.78. So the endpoint for pi over 4 is this one. This is the set of coordinates for pi over 4. When t is pi over 3, the corresponding point for pi over 3 is this one. Where is that in this picture? Pi over 3 is 1/3 of a pi. Okay, the semicircle is pi. So 1/3 of a pi is this one. And that is the terminal point or the end point, and this is the pair of coordinates for that point. When t is pi over 6, the corresponding point is, so starting from the initial point, we will trace an arc whose length is pi over 6. Okay? And the end point for that is this one. So that is the corresponding point for pi over 6. When t is 0, the corresponding point is this one, the initial point. And when t is pi over 2, the corresponding point is that one. Okay, that one. So that would be the coordinates for p. So in this video, we will present an informal proof for pi over 4. So why is it that the corresponding point for pi over 4 has this set of coordinates? Before we go there, let us review our understanding of similar triangles. So similar triangles, or triangles, are similar if and only if their corresponding angles are congruent. So in this example, okay, these two right triangles have different sizes, but they are congruent. Okay, so angle A is congruent to this. Angle C is congruent to angle D. Angle B is congruent to angle F. So that is our symbol for congruence. No, this is our symbol for similarity. Triangle CAB is similar to triangle DEF. And similarity between triangles brings a set of other characteristics. Okay, and this has to do with the ratio. The ratios of corresponding sides are equal. So in this case, the ratio of AC, okay, to AB is the same as the ratio of ED, this one, to EF. And not only that, the ratio of AC, where is AC? The ratio of AC to CB, AC, CB, is also equal to the ratio of ED to DF. And that is true for other ratios. There are in fact 6 ratios for similar right triangles. So the reason why I chose to begin this informal proof by reviewing our understanding of similar right triangles is because we will use it. So in this picture, we have a pair of similar right triangles. Triangle AEP, A, the smaller right triangle, okay, those are the vertices, and the larger triangle A, B, and C. So our goal here is to show that if this arc is an arc in our unit circle, has a length of pi over 4, the coordinates of the endpoint is going to be, that is our goal in this video. These two right triangles are similar. So that means the ratio of side PE to AP, okay, that is side PE to AP, is equal to the ratio of side CB, this is CB, to the hypotenuse of our larger right triangle. Now, pay attention to the big right triangle and pay attention to the angle 45 degrees. We already know what is sine of 45 degrees. We spoke about it in 2 or 3 videos ago. Sine of 45 degrees, which is opposite over the hypotenuse, which is this, opposite over the hypotenuse, is equal to square root of 2 over 2. So that means PE over AP is also equal to square root of 2 over 2. But what is AP? What is AP? What is the length of the line segment AP? It's equal to 1. Because AP here is the radius of our unit circle. Look at that. It's the radius of our unit circle. So this means PE, which is y. You know what? The length of PE, okay, the length of PE is the distance of point P from the horizontal axis. And that is what we call the y-coordinate of point P. So y, the y-coordinate of point P, is equal to square root of 2 over 2. The same explanation goes for the x-coordinate of point P. We have a pair of similar right triangles. Let us compute for cosine of 45 degrees. Okay, so pay attention to the big right triangle. It's equal to the side adjacent divided by the hypotenuse. And we know that to be equal to square root of 2 over 2. So this means that AE over AP is equal to square root of 2 over 2. AP is equal to 1. So that means AE, this line segment here, the base of our small right triangle, okay, this is AE, is equal to square root of 2 over 2. But you know what? That is also your x, because the horizontal distance of point P from the vertical axis is equal to the length of AE. So this distance, which we call x, is also equal to square root of 2 over 2. So with those two things put together, we have shown that the corresponding point for pi over 4 has these coordinates. And this point is the endpoint of an arc whose length is pi over 4.